Good morning. Here we are, the very last lesson in the circle unit and the very last lesson in the year. Crazy. Today, Unit 10, Classwork 14, Equations of Circles in the Standard Form. Okay. It's not going. Here we go. In the standard form. So a student was asked to write the equation of a circle with its center at the origin and a radius of 4. The student wrote the following equation: x squared plus y squared equals 4 squared, and was told that they were incorrect. What did they do wrong, and what would the correct equation be? So remember, if the circle is centered at the origin, then the equation is x squared plus y squared. Hold on. X squared plus y squared equals r squared. So if r equals 4, what they failed to do was square it. So in this case, what we really want is x squared plus y squared equals 16. Right. Here we go. Equations of circles in standard form. So what if a circle is not centered at the origin? What could you add or subtract to bring the x and the y coordinates back to the origin? Do you realize we started the year with transformations and we end the year with transformations? And our transformation is a translation. Everything comes full circle. So notice the scale of the grid. On your quiz on Friday, check the scale, because SAT, ACT loves to tweak the scale and see if you're paying attention to the actual scaling of grids. So we notice that each box is 2 square units. So scale. So our x, y, what would we need to do to get our x and our y back to the origin? Well, the x coordinate is 4, and so if we want to go home, that's home. We're going to go x minus 4. And if we want to go home with y, we got to go up. So that's y plus 2. So this is how, when you're asked, this is how we write a translation rule. That's the rule. All right, so we're looking at the center of, we're looking at circle C, where the center is at the point -1, 3. Scale is just fine here. What could you add or subtract to bring the x and the y coordinates back to the origin? What would take them home? So let's write the rule. X, y, every x and every y in that figure would need to go right 1, so that's x plus 1, and go down 3, y minus 3. What would the coordinates of P prime, remember we prime the image, what would the coordinates of P prime be after that same transformation? So we've got P, which is at the point -5 and 6. We want to move that same distance that we did when we moved the center back to the origin. So we're not moving P to the origin, we're moving the same distance, which means P prime would be -5 plus 1, 6 minus 3, which means P prime would be at the point negative 4, 3. Let's go and find that. 1, 2, 3, 4, 1, 2. So we're talking about moving P prime right here. What is the distance between the points? I'm going to go ahead and remind you of the distance formula up here. Distance equals the square root. Remember, this is an offshoot of the Pythagorean theorem. x2 minus x1, y2 minus y1. So what is the distance between C and P? D equals negative 5 minus a minus 1. So that's negative 5 plus 1 squared plus 6 minus 3. Oops, not the whole thing. Just a little bit. All right, which means then that D equals, that's negative 4 squared. Negative 4 squared is 16 plus 6 minus 3 is 3. 3 times 3 is 9. 9. 16 plus 9 is 25. That means square root of 25, the distance between P and C is 5 units. So what is the distance between the origin and P prime? Well, let's do that one. Let's see, P prime is negative 4 and 3. Let's write that here. Negative 4 and 3. So we want negative 4 minus 0 squared plus 3 minus 0 squared. Well, looky there. That distance is also 5. So this is going to lead us to the equation in standard form of a circle. All you need to think about is, what do I need to do to x and y to go back home? Here we go. So let x and y represent any point on a circle with center HK and radius r. By Pythagorean theorem, x minus h quantity squared plus y minus k quantity squared is the radius squared. We just do the opposite. So when it's minus h here and minus k here, what we're really doing is saying do the opposite. So if I have the point 3, 4, the opposite of 3, 4 is negative 3, negative 4. If I have the point negative 5, negative 7, the opposite is 5, 7. To get back home, we do the opposite of what we have. So, circle C, let's go back up and see circle C. Circle C has a radius of 5. And I know that because we use the distance formula, but we can also see that that's a 3, 4, 5 circle if we drew it out. So the center is negative 1, 3. So the center equals, let's go look at it again, negative 1 and 3. And our radius equals 5. So if we were going to write this, Then to get -1 and 3 back home, we want to do the opposite. And so in standard form, x opposite of 1 is plus 1 squared plus y opposite of 3 minus 3 squared. R squared, 25. And let's go see that that makes sense. To go home, write 1. What am I doing? 1, 3. Oh, I used P prime. That's fine. So to get back home, we want to go right 1 and down 1. Yeah, and we can see the radius is 1, 2, 3, 4, 5. Yep, okay, got it. All right, so we want to write the standard equation for each of the following. Circle B has a center of 2, 5, and a radius of 3. So here we go. X opposite 2 plus y opposite 5 equals 3 squared, 9. X opposite -3 is positive 3. Y opposite 1, 2 times 2 is 4. Let's do C and D together. We have X opposite 4 opposite of -7 is plus 7. And square root of 2 times square root of 2 is square root of 4. And we know the square root of 4 is 2. And for the last one, X opposite -6 opposite -1. And 7 times 7 is 49. So here we go. If given an equation, to find the center, we do the opposite, right? So to go from the origin to the point, we still have to do the opposite translation. So here we go. The center point is, well, what's opposite of -5? 5. What's opposite of 2? -2. And the radius, what's the square root of 9? 3. Here we go. Center, opposite of +9, -9, -9. Opposite of +4, -4. And the radius is radius squared is 81, which means the radius is 9. Center, opposite of 1/3 is -1/3. Opposite of -6, +6. And if radius squared is 49, then our radius is 7. All right, these last two, I'm no good at drawing, so best efforts here, but I'll show you how I think about doing it. First, we need to identify the center and the radius, and I'm going to sketch it in. I'm not looking for art projects here. You can use some of the tools if you prefer, but let's go ahead and identify the circle and the radius, and then I'll show you what I do. So opposite of 1, so my center point is going to be opposite of -1 is 1. And opposite of 3 is -3. So let's go find 1, -3. 1, -3, and put our center point there. What's our center? And r squared is 4. So remember, it's r squared equals 4, which means r equals 2. So I'm going to go out 2 from the center point, and I kind of sketch that in, and then I just sort of fill it in like that. It's close enough. Actually, that's bothering me. Try to get it. That's the beautiful thing with doing it on OneNote. You can erase. There, that's better. All right, let's look at our center. Our center is opposite -2 is 2, and opposite 1 is -1, and r squared equals 16, which means r equals 4. So we want to go to the point 2, -1, 2, -1, that's right here. And in this case, we go up 4. 1, 2, 3, 4. 1, 2, 3, 4. Boom. 1, 2, 3, 4. Boom. 1, 2, 3, 4. Boom. All right, here we go. All right. Best effort. All right, folks. Let me know if you need help. Always think about that translation home, or if you're home, that translation back to the center point where your circle moved to. Have a great day.